Hey everybody, Melissa here, and today we're going to be learning about dividing polynomials. So what that means is that in problems 1 through 3, we're going to be using long division. Yeah, the same kind of division that you learned how to do in elementary school, we're going to be reusing it for polynomials. And for 4, 5, 6, and 7, we'll be using this new method of division called synthetic division, but it's supposed to be a lot cleaner way of dividing rather than using long division. And keep in mind that for all and any of these problems, we will expect to be dealing with remainders. So let's get started. Okay, so here we have number 1, 3x squared minus 14x minus 5 divided by x minus 5. So I went ahead and already set it up in a long division bar, but before we get started, as a refresher to how long division will work in this case, let's start with just dividing numbers. We always look at the outer number and we ask ourselves, how many times does it go into the inner number? And if we start here, we know that 6 doesn't go into 2, so we will move over 1 and we ask ourselves, does 6 go into 21? And we know that it does 3 times. So after we put that number up here, we multiply them together, put that result underneath, subtract to get 3, and then we also bring down that outer number, or the number on the left, and now we ask ourselves, how many times does 6 go into 36? And we know that to be 6. So how does that translate when we have variables being added and subtracted to each other? Well, it's very similar. So we can ask ourselves and just ask ourselves only about this x. We don't even have to worry about this minus 5 that's right here. So with this first outer variable, we can ask how many times does x go into 3x squared, or what do we need to multiply to the x to give us 3x squared? And we know that to be 3x. So when you figure out what multiplies to give you the first term inside of the bar, be sure that you line it up with its respective term. So if I know that x times 3x gives me 3x squared, I'm just going to line the x's up with each other. Okay, so we have our first term. So now we know that we need to multiply and just bring it down. So 3x times x gives us 3x squared, and we also multiply it to that minus 5. So we get minus 15x. And same thing applies where we subtract. So keep in mind that if we are subtracting a negative number, it's going to cancel, or it's going to turn it into plus. So I'm going to cross off this. I know that that's 0, and then I know that this is also a plus now. So then I have x, and also bringing down this 5, we have x minus 5. So now we can ask ourselves, does x, or how many times does x go into x minus 5? And even with just looking at the front numbers, it's safe for us to say, well, we know x goes into x 1 time. So we can add a plus 1, and same process, whatever number you add up here, multiply it to each term on the outer part of the division bar, so that we get x minus 5, and of course we must subtract, but luckily these cancel out and we don't have a remainder on this one. So this is our final answer. Okay, so now we're looking at number 2, x to the 4th plus 2x squared minus x plus 5 divided by x squared minus x plus 1. So notice that our dividend has 4 terms, but when I wrote it out in our division bar, we have 5. So I made a placeholder for the cubic degree, because notice that our dividend, it didn't have any term with an x cubed. And when we use long division and later on when we use synthetic division, whenever there is a missing term of the descending degrees, we have to put a 0 placeholder wherever it'll fit. Okay, so same thing in mind. Let's look at the outer term x squared and ask, what do we need to multiply to x squared to give us the first term, x to the 4th? Well, let's line it up with its respective parts. So we know that x squared times x squared gives us x to the 4th. So then now distributing this x squared to all of the terms in our divisor here, x squared times x squared gives us x to the 4th. And then here we see why we need the placeholder, because x squared minus, or x squared times negative x gives us negative x cubed. And then lastly, x squared times 1 just gives us plus x squared. Put the parentheses over and subtract. Now be sure that when you add parentheses around our polynomials and we subtract negatives or we subtract positives, that we're really changing the signs just in case. So then this becomes a plus, and then this becomes, just a reminder that that's a minus, and then so this cancels, then we have x cubed plus x squared, and don't forget to bring down the term that's 1 to the right, so minus x. Now we gotta ask ourselves, what do we need to multiply to x squared to give us x cubed? And we multiply it by a positive x. So going back again, multiplying this to all of these terms and putting it down here, x times x squared is x cubed, x times negative x is negative x squared, and x plus x is the last term. Parentheses, subtract, changing the signs. This is minus, okay. Then we have 2x squared minus 2x, and then bringing down that plus 5. So now we're looking at 2x squared. How many times does x squared go into 2x squared? And then we know to get that, we will multiply it by 2. So going back again, 2 times x squared, 2x squared minus 2x plus 2. Parentheses, subtract, changing the signs, minus, oops, hopefully I have enough room. These cancel, and we are left with 3. So we're left with 3 as our remainder. So in this case, what we do with our remainders is, since we have a positive 3 to the end of our quotient, it's going to turn into a fraction. 3 over our divisor, this whole thing, so 3 over x squared minus x plus 1. And as weird as the remainder looks, that is our final answer. Okay, so our last long division problem, number 3. X cubed plus x squared plus x plus 2 divided by x squared minus 1. So we can go ahead and straight into it. What do we need to multiply to x squared to give us x cubed? We know that we need to multiply it by x. So let's distribute this to our dividend. X times x squared is x cubed, and x times negative 1 is x. So always remember to line up the respective terms with their same degrees. Notice that we did not get a term for the second degree, or a squared term. So let's put a placeholder, plus 0 x squared, just so visually we know that we still have to add it up. And following the same rules, of course, as dividing, later on we will still bring down that 2. But let's focus on this first. Parentheses, subtract, these are gone, and then this also changes the sign, so we got x squared, and then we also know that this changes into a plus, so x squared plus 2x plus 2. Okay, so what do we need to multiply to x squared to give us x squared? We know that that's just going to be positive 1. Same process. Let's multiply 1 times x squared gives us x squared, and then line it up with its respective parts. We do have another placeholder that we need to put, 0x, parentheses, subtract, these are gone, then we have 2x, then we have 2x plus 3. And that is our remainder. So again, whenever we have remainders, if the first term is either positive or negative, that determines whether it's plus or minus. So since it's positive, we say plus 2x plus 3 over the divisor x squared minus 1. And that whole thing is our final answer. Okay, so now we have the first problem that we have to use synthetic division on. So 4x squared minus 13x minus 5 divided by x minus 2. So I already have this synthetic division set up, but let me go into explaining it. So notice that it kind of is like our regular long division bar. We do have the divisor on the outside and the coefficients. Notice, the coefficients of our dividend on the inside. So I got our divisor by just taking x minus 2. If I had that set equal to 0, then I have x minus 2. So that's just where that comes from. And then the 4, the negative 13, and the negative 5, again, are just the coefficients. So once you have it set up like this with just the numbers and the proper divisor on the outside, the first step for synthetic division is to bring down the leading coefficient. In this case, this is the 4. So once we have this number here, we are going to do the same as like with long division. We multiply the divisor to our first term in the quotient, and we put it right here. So 2 times 4 is 8, and same thing, we will just add it as it is. So we have negative 13 plus 8, and I guess that's the difference between long division and synthetic division. With long division, we're used to subtracting the numbers that we put, but in this case, remember to add it. So it'll be negative 13 plus 8, and we get negative 5. So now negative 5 times 2, we get negative 10, and adding these, we get negative 15. When we have all of our numbers at the bottom of our synthetic division bar, though, we're not done because we know our answer has to be a polynomial. So what we do to get our answer is we use these numbers as the new coefficients for our answer. So our first term will have a 4, and we can determine what degree it needs to be by just taking 1 degree less than the one that we started off with. So if I started off with 4x squared as part of the dividend, then the first term of my quotient will be 1 degree less. So it'll be 4x. And following the order of standard form, we always go from highest degrees of the variables first, and then plain old constant numbers last. So since we can't go any further in degrees, our next term is just going to be minus 5. And since we do have negative 15 last, that means we have to make a remainder out of this one. So we do expect it to be negative 15 over our original divisor x minus 2. And that is our final answer. And I should say too that I kind of actually didn't pick any synthetic division problems that ended without a remainder. So just a reminder that if you end up with 0 in the last slot, then you won't have a remainder. So say that I had a 0 right here and it was just 4, negative 5, and a 0, then my final answer would have just been 4x minus 5. But for the sake of this video, I did pick more challenging problems, so they will all have remainders. Okay, so now moving on to number 5, we have x to the 4th minus 5x cubed minus 8x squared plus 13x minus 12 divided by x minus 6. So here I have it all set up again. We know that the coefficients will be 1, negative 5, negative 8, positive 13, and negative 12, with our divisor being positive 6, since our whole divisor was x minus 6. So let's start off bringing that 1 down. 1 times 6 is 6, and then add these up. We also get 1. 1 times 6 again. Negative 8 plus 6, we get negative 2. Negative 2 times 6, we get negative 12. Adding these, we get 1 more time. And the last number is 6. Negative 12 plus 6, we know, gives us negative 6. So let's use these results to make our polynomial answer. So notice that our highest degree was x to the 4th. So we can expect the first term to have a coefficient of 1 and a degree of x cubed. So that will just look like that. And let's go ahead and keep going in descending order using the coefficients, keeping in mind the degrees as well. So that means the next term should be plus x squared minus 2x, and we have run out of x's to use. So then we could say plus 1 as the constant, and since we did not get 0 as the last number, that means this negative 6 is going to be our remainder. So it will be negative 6 over the original divisor, x minus 6. And this whole thing, that whole thing is our final answer. Okay, so now we're down to our last two problems. Slightly different instructions, but still using synthetic division. For these ones, we will have to use synthetic division to evaluate the function for the indicated value of x. So that's the same exact thing as asking, what does f of x equal when x equals 3? So I know we're used to plugging it in just to find that number, but these problems will show how to use synthetic division to get the same exact result. So first, notice that we have x to the 4th plus 6x squared minus 7x plus 1. But within my synthetic division bar, I have 5 terms that's coming from the dividend. So because we didn't have a term to the 3rd degree, I put a 0 in its placeholder because, the 1 was the coefficient for the x to the 4th, and the 6 was the coefficient for the 2nd degree, or the x squared term, and we did not have an x cubed term. So this is where that 0 is coming from. Don't ever forget to put placeholders if you notice that there's a certain degree missing. So we can go ahead and just bring down that 1, multiply it to the divisor, and add up. 3 times 3 is 9. 9 plus 16 is 15. 15 times 3 is 45. Negative 7 plus 45 is 38, and 38 times 3 is 114. Adding up that last column, we have 115 on the end. So just like with the previous problems that we did, we had to come up with a whole answer in polynomial form with a remainder. But since this one is just evaluate f of x for the given value of 3, our final answer would just be f of 3 equals 115. And that's it. We don't even have to write out any long polynomials like we did for the last ones. Okay, so now we're down to our last problem. Same thing as number 6. Evaluate the function for the given value of x. So I already partially set up the synthetic division bar on this one. We know that 5 has to go on the outside, and let's start by putting the coefficients in descending order of the degrees that they're in. So we have negative x to the 4th minus x cubed minus 2. Our highest degree is 4 with the coefficient of -1. And then we have another -1 as a coefficient for the third degree. But notice that it goes straight from x cubed to the constant -2. So we are missing a term for the second degree and the first degree. So expect to put 2 zeros as placeholders for those missing terms. So again, we're putting 2 placeholders, 2 zero placeholders for the missing x squared and x term. And then that last number that we could put then is -2. So that covers all parts that we'll need, and we could go ahead and divide. So bring down that -1. -1 times 5 is -5. Add these up, we get -6. Multiply by -5, we get -30. Bringing that down again, -30 times 5 is -150. Bringing that down, -150 times 5 is -750. And then adding these two together, those last numbers, we get -752. So then, yeah, as large as that number is, we can say then that f of 5 equals -752. And that's our final answer. So hopefully these problems helped clear up how to use long division and synthetic division to divide polynomials, especially with remainders. So thanks guys, and good luck.